Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Nur Nashiba binti Wan Muhammad Arshad. Today we'll be presenting my research entitled Impregnation of Single-Wall Carbon Nanotubes with Thiosemicarbazone Derivatives for Cobalt Removal from Aqueous Solution. Before we go further, let me introduce a little bit of this research. Cobalt is a trace metal that can be found in water due to natural processes. High concentrations can lead to adverse health effects. Hence, finding the most effective and efficient methods of removing heavy metal from wastewater is crucial. Thus, adsorption has been known as a viable and advantageous technique for water treatment compared to other methods. Adsorption process was launched to be an optimizing technique to remove trace amount of exormate from aqueous solution. Consequently, carbon nanotubes are matched as adsorbent materials due to effective and locally available material. The objectives of this research are to enhance the adsorption capacity and to enhance the selectivity of the carbon nanotubes for cobalt ion. There are some problems occur for this research. First, the problem statements are how to ensure the uniform of impregnation single-wall carbon nanotubes. Second, how to improve the adsorption capacity, selectivity, and reusability. Third, how to measure scalability and also cost effectiveness of the process for potential application. Carbon nanotubes contain unique properties. Some of it are high strength, electrical conductivity, and thermal stability. Thus, carbon nanotubes are used in a wide range of sectors due to their unique properties which make them valuable. In electronics, carbon nanotubes create transistors with high performance. While biomedicine, carbon nanotubes are used for drug delivery to increase the efficacy and reducing side effects. While in water purification, carbon nanotubes work as a filter for removing contaminants due to ability to absorb wide-range pollutants. For this research, the impregnation of carbon nanotubes was carried out. Impregnation of carbon nanotubes refers to the process of incorporating carbon nanotubes into the matrix material to enhance properties. This is crucial for ensuring that carbon nanotubes are well distributing and effectively bonded to the matrix. This technique is commonly used in creation of composite materials where carbon nanotubes are dispersed within host matrix such as polymers, metals, or ceramics. The advantages are allowing good dispersion of carbon nanotubes and can be used with a variety of matrix materials. Thus, in this study, carbon nanotubes was impregnated with thiosemicarbazone derivative. Thiosemicarbazone is known for their strong affinity to metal ions through coordination bonds, can be used to functionalize carbon nanotubes to enhance their selectivity and adsorption capacity for cobalt ion. Knowing that carbon nanotubes have high surface area, chemical stability, and its functionalization, making them promising candidates for heavy metal adsorption. Next, we go to the methodologies. The first step of this research is synthesis of benzoyl thiocyanate using 3-bromobenzoyl chloride. 3-bromobenzoyl chloride was added dropwise to a stirring acetonitrile solution with ammonium thiocyanate. A wet precipitate of ammonia chloride was formed immediately and filtered. The filtrate was added dropwise into a stirring thiosemicarbazone with acetonitriles. Next, the solution is refluxed for 4 hours at 90 degrees with constant stirring. The second step is synthesis of ligand. Benzaldehyde was added dropwise to a stirring acetonitrile solution into a mixed solution and continuous reflux for 2 hours with constant stirring. Then, the solution was poured into a beaker containing some ice cubes. The precipitate was filtered and washed with little ice-cooled methanol, then dried in a vacuum desiccator. The crude product was purified by recrystallization from methanol and the percentage yield confirmed about 60%. Then, for the next step is the impregnation single-wall carbon nanotubes with ligand. The amount of 1 gram of single-wall carbon nanotubes is weighed and added into 50 ml of ethanol in closed vial. The mixture is placed under retort condition for 1 hour under constant pressure. In a quantity ratio of 1/1, 1 gram of solid ligands were added into carbon nanotubes mixture and reflux for 4 hours at 90 degrees Celsius. The sample was filtered and dried in hot oven at 100 degrees Celsius and kept in desiccator for characterization. Then, the sample undergoes absorption study. In order to evaluate the absorption capacity, 10 mg of the carbon material was dispersed into 10 ml of 5 different concentrations at 10, 20, 30, 50 and 80 ppm of cobalt ion stock solution was prepared. The mixture was shaken for about 1 hour in aqueous solutions, then undergo determination using ICP-OES. After undergo various methods, the sample was analyzed using various characterization. The first analysis was FTIR analysis. The table above shows the functional groups and the peak appears on the spectrum. To make it strong, another analysis using proton NMR were analyzed. The table below shows the aromatic appears at the peak of 7.98 ppm, while NH stretch appeared at the peak of 1.27 ppm, and the carbon double bond carbon appeared at 480 ppm, while the aliphatic from Thiosemicarbazone derived at the peak of 7.83 ppm. This shows the strong image of the ligand that was synthesized from the method. After impregnation process, the sample undergo SEM analysis. There are slightly different between raw single-wall carbon nanotubes and also single-wall carbon nanotubes impregnated with ligands. As shown from figure 8, the resulting samples have morphology of nanotubes were rope-like, curved and highly tangled and agglomerated. The attachment of ligand and single-wall carbon nanotubes was shown at 15K magnification at range of 2 to 5 micrometers, showing the wide and tangled strains on the surface of single-wall carbon nanotube. Percentage of C element were 90% and were 3%, O were 2% and S were 3% for single-wall carbon nanotubes ligand reported from SEM EDX. For absorption study, absorption isotherm was carried out. The first isotherm is Langmuir isotherm. The Langmuir equation was used to fit the data and the absorption parameter obtained, such as maximum absorption capacity Qmax, and the Langmuir isotherm constant were shown in the table. The R-square values represent the coefficient of determination, which assess the goodness of the fit of the Langmuir model. The R-square values, the data range from 0.677 to 0.98, suggested a reasonably good fit for the Langmuir model. The higher the R-square value are, the closer they are unity or 1, which indicate an excellent fit between the experimental data and the Langmuir equation. In addition, the Freundlich models and values, which indicate surface heterogeneity or absorption intensity, varied at 1, which is the favorite value of intensity. The metal ion cobalt absorbed onto the single-wall carbon nanotube ligand primarily via the internal surface by particle diffusion, which is consistent with absorption process took place. The findings show that metal ion cobalt-2 can effectively absorb using the Langmuir and Freundlich isotherm models. In conclusion of this research, the impregnated single-wall carbon nanotubes with thiosemicarbazone derivative, which is the ligand, has yielded significant results for metal ion cobalt-2 adsorption. The chemical characterization of the synthesis ligand reveals the presence of amide group and aliphatic compounds, particularly on thiosemicarbazone. The active functional group and significant molecular structure indicates its potential for further impregnated stage with single-wall carbon nanotubes as an adsorbent for metal ions, specifically cobalt-2. The data revealed that the Langmuir model, which suggests that cobalt-2 ion adsorb on single-wall ligand surface, best represented the adsorption data. Respectively, the elimination of metal ion cobalt-2 was reported to be excelled for adsorption study. Thus, the impregnation of single-wall carbon nanotubes with thiosemicarbazone derivative, which is the ligand, has ideal performance for adsorption of cobalt-2 ion. That is all from me. Thank you for lending me your ears. Assalamualaikum warahmatullahi wabarakatuh, and very much thank you.